Hello and welcome to another video. Today we got an MSI B450 Gaming Plus on our bench from a viewer. He said that after changing it from a case when he wanted to upgrade his graphics card, he after that saw an arc, he said, close to the RAM sockets. So there might have been a power surge of some sort, but I also suspect there might be broken components somewhere, like physically, because he changed the case and after that something happened. So let's try to figure out together what could have happened here. Because we know that there might have been an arc for something, I would want to go ahead and start with resistance checks, like we usually do. So let's have a good look at the 24-pin connector. So we are at the 24 pin. Bottom left is 3.3 volts, high resistance. 5 VSB, fourth from the top left, high resistance. Then 12 volts, second from the top left, high resistance. And second one from the top right, 5 volts. Oh yeah, that looks bad. Oh yeah, we might have a 5 volt short. Yeah, 16 ohms on 5 volts is way too low. So we will definitely have to go over to voltage injection and see what is shorted here. This might be the 5 volt dual, to be perfectly honest. I've seen it multiple times. Yeah, it is. Let me show you. I've seen this on MSI multiple times. Right here. This is a P-channel MOSFET, I think it is. It is some sort of MOSFET, either N-channel or P-channel, but I think it's P-channel. And the tab that you can see there, that's the output, and that is 5 volt dual. And often when you have a 5 volt VSB short or a 5 volt short itself, you very often have an actual 5 volt dual short. And if you probe that now, we can see 5 ohms. So let's get a let's get my thermal camera, get the power supply hooked up so that I can show you the current, and let's inject some voltage. So now you can see I have 1 volt. You can see it at my power supply right there. It is connected to this PIC that I will be injecting voltage into that MOSFET, and then we will go around with the thermal camera and see what gets hot. So 230 milliamps, and I can see something glowing right here. This looks like the VDDP regulator. Yeah, that is probably shorted. Yep, pretty sure that's all. Let's get the macro lens in here. So to see once more. Yeah, there you can see it. So what probably happened is that that controller is shorted from the input to the output, and that the 1 volt at the end goes into the CPU probably, or this just pulls it to ground. No idea what exactly it is. But yeah, it shouldn't be getting hot from just 1.1 volts, as you can see with 230 milliamps. So I know what controller that is, and we've replaced that in a previous video. So yeah, I have these in stock, luckily. So let's see for that, desolder it, and put another one in, and then check voltages once more. So right here, you can see the actual component, and it actually has a hole in it. So it's probably even shorter to ground. And here is the replacements that I have. So we make sure that the stripe is at the right side close to the PCIe slot, so that we know how to solder it back in. And I think we don't even need hot air, because the M.2 and the PCIe is quite close to here. So I would want to not use hot air. So let's put leaded solder on both sides. So get leaded solder on one side completely, then let's attach it. Let's put it on the other side. And what we now can do is I like to just put the soldering iron across both legs in order to just remove it with the soldering iron. Not working as great as I thought. Yeah, the idea was okay, but the execution wasn't great. Let's just use my hot air and take it out. The area should be hot enough for this to come off easily without melting anything close to it. Right there. Component is off. Now we have to clean up the mess that I made with some wick. So this should be fine now. Let's see here. So let's take off the solder that is on here also. And let's get our nano sponges with some IPA. Let's remove that solder ball that is on here. And we will have to see if that resistor needs to be resoldered maybe here. But it should be fine. So let's get the actual new component in here. So there's our component. And we need the stripe to the right. So let's flip you to there. So it's lined up. Let's see now. Let's see if I can like tack on a single point there. Okay, for whatever reason, this soldering tip does not want to get hot enough in order to melt the solder properly. Yeah, I will just hot air this in because this soldering tip does not want to play nice with me. So I don't know why I struggled so much, but this took like 20 minutes to solder in. These legs just wouldn't either they wouldn't want to stick to the pads, or they would only want to stick together, like the solder from them. Like I had to take this off, clean each of the single legs of it with the soldering iron, and then hot air it on. Only then I was able to solder this onto here properly with every leg connected. Like this component was fighting me so badly. Like this might be one of those that came from AliExpress where all of the legs are so oxidized that they just wouldn't want to hold any solder, and if only to each other. Like that was awful. Like I've replaced this kind of component and at this position so many times before, and I've never struggled as much as I did here. Like this was awful. This took way too long. Well, now it's in, and now it shouldn't be a problem anymore. And we have, like we said, the stripe to the right side to the PCIe slot. We have it right here. And let's check for our resistance, then go to our overhead camera once more. So at the same position, let's look at our resistance. So let's see at this tab now. And now we have high resistance. You can see 1 kilo ohm. And let's see for our 5 volt input. And the 5 volt input is still shorted. So the 5 volt input has another fault that is not that input. Okay, so let's do the same thing once more. I wouldn't have expected that. Like most of the time you have a single thing that is faulty and not multiple things. So let's see then. What I do is, again, I'm going to hold it into here. So let's see, we have 70 milliamps. And now, of course, it's skewed because of the hot air that I was using. So let me see if I can find anything that is heating up. But we have very little power consumption. We only have 60 milliamps at 1 volt, as you can see. So let's increase the voltage a little bit so that we can actually get some amps into here. Okay. Still can't really see anything. Let's go for 5 volts, actually. 400 milliamps. And all I can see is... Oh yeah, there is something. Oh yeah, it's burning. There it is. Let's see, where's the macro lens? This is close to the PWM controller at the top right there. So if you can see, this is just burning up. Okay, let's then go under the microscope and see what that is. We might need to take off the coolers for that, but let's first see. So I have no idea what this component is, to be honest. I think I've seen this thing faulty once before, but I don't really know what it is anymore. But I definitely have to take out the heatsink in order to be able to take that out. So let me quickly do that. So this component, I don't remember what it was, but I've had this thing faulty before. Oh, I don't... we will have to see in the board view what this is for. This might be some protection circuit that has blown, but I'm really not sure. So let's take it off. Let's put leaded solder on here. And what we'll do, we just hot air this off. Just make it right this time. Just blast it off of here. So that is off. Let's clean it off a little bit so the pads aren't so big anymore. And let's go get into a board view then, because I have no idea what that was, to be honest. The other one I knew actually, but this one I don't know. So we need this number, where is it? Right here. MS7B86 version 1.0. Let's get a good look into the board view then. So here we are in the board view, and let's have a look. It's this component right here, NCT3933. This takes, for example, VCC5. So because this takes VCC5, I think we might have had an over voltage at 5 volts. That is probably what happened. SDA and SCLK. So this has some kind of communication and clock with something. So with multiple controllers, yeah. This might be a thing for overclocking or something. That this communicates with other controllers. What else does it take? There's some sort of signal coming in through 10k ohm resistor. No, this is just ground. This is not fitted. Okay, what else is there? There's a single more through a 0 ohm resistor that goes into another controller. Interesting. And I don't know what this controller is for. Timer, reset, proc hot. Yeah. It might even work without this thing, to be perfectly honest. But let me see if I can find this anywhere on one of my donor boards, and then we can put it onto here. And I actually found one. This is a donor board that I keep taking parts of. And there's an NCT 3933 on here. And that is the same that we need right here, an NCT 3933. Very well. Let's take it off of the donor board and put it onto our patient. So interestingly, the marking is completely different on this one, but we will still take it. And we will put it on there and then see. Because I trust my board view, to be honest. And just because the markings are a little bit different doesn't mean that the part isn't working as it should, or isn't that part. I don't know what it is. I'm struggling really badly with soldering today. Like, these should be really easy, and I'm just struggling so hard, and it's taking me so long to get anything onto there. But yeah, it is connected. I'm perfectly honest, I'm just winging it here, because I don't really know because of the orientation. The other one was also placed like upright from when looking at it from here. And now it's also upright. So we might get no, maybe not sparks, but something might glow right here. We will definitely check for the resistance first. And yeah, it is on there. Let's go on to the overhead once more. So the last short circuit that we were chasing was on the 5 volts. And let's see for that now. So it's the second pin from the top right. And now we have 500 ohms. And 500 ohms could definitely be okay. So, I'm very interested what will happen now. We have a CPU of the viewer, a 5700G. Never had this new of a processor here to test anything with. But we will see. Let's also check, because we didn't do that, the 12 volts from the CPU. Let's also check the 12 volts from the CPU, because we haven't done that before. So, 12 volts from the CPU, not shorted, and the 12 volts into the phase, also not shorted. Okay, so we don't have a problem with that, because one of the things is, if 5 volts is shorted, there are many things on that 5 volt line. For example, the PWM controller very often is also on the 5 volt line. Then some MOSFET drivers could also be on the 5 volt line. And many other things, like the audio controller, could also be on the 5 volt line. It could have also fried that. So, let's then... what will we do? Let's go into passive power consumption, I think, with the board in, and go from there. So, we are at the point of putting in 5 VSB into here and see what happens. So, let's quickly do it and see for the power consumption. 90 milliamps, that looks fine. Okay, 90 milliamps is a good sign. I would expect a little bit more, to be honest. But let's see for some voltages. Let's see if that 0.9 volts is now running. That where we replaced that controller. And let's see if we have 1.8 somewhere here. No, not here. This is probably VPP. That is also not present. Let's see on the BIOS chip if I can see a 1.8 signal anywhere. Nope, I cannot see the 1.8 volts anywhere. There's probably a 1.8 volt standby somewhere that I cannot find currently. But I think it's just time to try to power this on. And who knows, maybe this will go up in flames and will explode in my face now. And maybe it won't. So, here goes nothing. And there's nothing happening. Yep. So we definitely have voltage, but it's not turning on. And I would guess it's that we're missing the 1.8 somewhere. And it might be right here under the DDR controller that we need 1.8 volts there. And I think I can see something in that is wrong there, just through my black eye. Let's go to under the microscope and see for that. Let's swap scenes. And exactly that is what I seen. I saw that something was burned. And this looks like it's an inductor. That this is actually an inductor that leads 5 volts into that controller. And from that controller then puts 1.8 volts out. And I think what happened is, that is the arc that he saw, that too much voltage, like 12 volts, probably went into the 5 volts, burned through that inductor, and if we're lucky, that controller is still alive and still produces 1.8 volts normally, and if not, that is shot through and will lead 5 volts straight into the output. So let's get the multimeter on here. So let's see. This thing is definitely shot through. So there's really high resistance here. Now the big question is from this to there. And it's shorted. Very nice. So we had this happen before, where the input, this side, is shorted to the output right there. And what this will do, it will send 5 volts from here straight into the 1.8, straight in the CPU, and will kill the CPU. So very well that this was here. This protected it from not taking the 5 volts in, putting the 1.8 volts out, but the CPU might already be dead. So another thing that we will have to work on is to take that controller off, take that inductor off of there, and replace all of it. I'm not sure if I have these in stock anymore, to be perfectly honest. I will have to see. But let's first take it all off. So let's get that inductor off. And also the controller. I will put some protective tape onto the DDR slots, just to be sure. Oh, this seems to be burned onto here. Okay, now it's gone. So the inductor is off. And you could just leave a solder bridge there, to be perfectly honest. Like, I will see if I have an inductor that I could put on there, but you could also just bridge it. So now let's take off this buck converter here. And this will need quite some heat because I cannot let it solder under it to lower its melting temperature. So the controller's off. Let it solder onto here. So I will need to go on a hunt if I can find one of these controllers. So give me a second. So luckily I found one on a donor board, and I will definitely have to order some because I think this is the very last one that I have. So I will have to order like a 10-pack or something of those so I have them in stock, because they seem to fail all the time. And they fail in a very similar way. Like, they fail with their input shorted to their output. So let's take this one off of here, off of the donor board, and put it onto our patient. And then hope that everything is done. I might even be able to take a inductor then off of here somewhere. I will have to see if this also has that type of inductor that the patient uses. So component is off. Let's see. Is there an inductor here somewhere? These might be actually power inductors right there, but they might be too big. But I will take one anyways. Let me quickly see that these are inductors that I taken off there, but I'm pretty sure. Yup, those were inductors that I just saw there and that I took off. So we can definitely put that inductor also there. So there's our chip. Here's our inductor. Let's first... The inductor is definitely bigger than... Oh no, it actually fits there quite well. Okay, so that might even be the exact right one. So it is one side on, the other side will be hot aired on. And let's see what direction this needs to go on. This needs to go like this onto here. Okay, I will have to hold that component with tweezers, or else it won't solder onto here. I think we should be fine now. So, let's control. So, from this side, right here, to there should be 0 ohms. Right, 0 ohms. We have continuity through the inductor. And then from here to that inductor, we should have high resistance, and we do. So before we had a short from 5 volts input to the 1.8 volts here, and this was burned and didn't let the 5 volts through to that controller. So I'm very interested now if now the board wants to work after all we done to it. So let's see then. Passive power consumption. Now I want to see 150 milliamps of this thing. Let's see. 110. 110 is fine by me. That is more than it was before. And if we now check voltages, the 0.9 volt controller that we changed, the 1.8 volt controller that we changed, and everything there like it has to be. And now I would think that we have a reaction to the power button, but that doesn't mean that it might still blow up in our face right here. But, well, we have done a lot to this board. There was a lot damaged here. So, let's then turn this on and see. Here goes nothing. 1.5 amps. And this looks like either a brain-dead CPU or a dead BIOS. Let's take a known good CPU then. So once more with a known good CPU. 2.3 amps. That looks a lot better. And now we have changing power consumption. 5 amps, you can see it. And I would expect that we get a post screen every second now. And there it is. Whew! Now it's on. Okay. Well then, let's turn this off once more. Question now is that processor destroyed? So, what we do, let's see for the BIOS that is on here. So let's make this a little bit bigger, get a keyboard onto there so I can actually get into the BIOS. So turning the board on, we can see the power consumption. So the board turns on quickly now. Let's get, there's the BIOS. And what version do we have? BIOS build date is from 2018. So this might have a BIOS version that does not support that processor. So let me get a USB stick ready with a BIOS version so that we can flash this. One moment, please. So there's the BIOS update. Let's run this through. And then after that, we can see once more for the processor. So the BIOS is looking completely different now. So let's now see. Let's turn this off together and put in the 5700G and see if this works now. So 5700G in here and turning this on. Let's see now. 1.5 amps, 1.6 amps. No, nothing. So I'm not too sure if this CPU is brain dead or just not supported. But I'm pretty sure it's brain dead. I will try this on a different board probably. But yeah, this will be the end for this repair. The 5700G I will look in another board, but I'm pretty sure it's just dead. But the board is fixed now. This board probably took 12 volts to the 5 volts line. this is what I think has happened here, and this is my experience that that will tell me that, because I've seen something like this before, because multiple things on the 5-volt line just shorted and got damaged. And we had the 0.9 VDDP controller. We had that one weird controller to the top there, what I don't know what it exactly does. Then we have the 1.8 volt controller and the inductor that has burned up. And yeah, now the board is working, thankfully. So I hope you learned something in this video. All of my tools, as always, are linked in the video description. If you want to get one of these current meters that I use, email me. I have that also linked in the video description. Thank you very much for watching. This was MainboardMedic. Thank you very much, and goodbye.